Okay, welcome everyone to my talk about fighting bad PL SQL. I had a similar talk some years ago, and that was more about metrics, and this time I'm going to show you more about concrete facts, rules that are checked in SQL Developer, and how you can identify bad SQL there. But before I start, I would like to set a bit the context, start with an introduction. And even before that, just short information, I'm also an employee of Trivadis, and Trivadis is a sponsor of this event, and you find us on the level 1, right on the right side of the stairs. I'll be there on the booth after this talk for an hour until 12 o'clock to answer questions. You have the chance that I show you some things live there with screen sharing and so on. Whatever you like, take the chance and visit us there. So let's get started. And the first question I'd like to ask is, where is the code? And of course, we heard Jasmine before, the code is in Git, for example, or another source control system. But I do not really mean that. I mean, when you look at the typical application, you have an application which run outside of the database, and you have a part that runs inside of the database, and you access the database via SQL and PL SQL. So what are the options there? When we look into Apex as an example, here's a report I show you based on a more or less complex query. I can write that in Apex directly, and it is stored as part of the Apex application. It has some advantages when I deploy the stuff. Everything is together, the whole application. But when I want to reuse part of the report, it often happens that you just copy the whole SQL statement to another one and use it there with another set of columns, other order by, other group by, something like that. You can avoid that by extracting the relevant parts into the database, create the view, for example, a relational view, and put everything, the business logic or the logic of this query there into this view. And then the result is that the access from the GUI application, in this case, Apex, it's much simpler. You just access this view, add some where clause, maybe an order by, and so on. So it's easier. Both approaches have their advantages, but the main advantage is when you separate that from the UI, you separate that also in the version control, and you can easier access that for such tools I show you later. In the other case, it's somewhere buried in Apex in their data dictionary. You have to extract that, and if you can do that, you cannot point the editor into the right place within Apex or the GUI tool you are using. And another example is PL SQL. Here, a process in Apex. This may contain several hundreds of code. In this simple example, I show how to calculate the commission or something like that. And also this can be put into the database via a PL SQL package, for example, where I provide a function to calculate the commission, and then the call from Apex is much smaller. And in this case, yeah, I also gain some performance advantages because the package is also pre-compiled in the database. So that's one point where I find the code, it has advantages when I do some static analysis. I will come back to that point at the end. So when we talk about software quality, then it's quite a difficult topic. Just imagine you are part of a development team, and in your development team you do regular reviews. In one time you are the author and show your code and get feedback from the others, and in other reviews you are the reviewer and look at the code and give feedback. And you have an open feedback culture. You say when you like something and why you like it, and you say when you don't think it's a good solution, and you argue why you think this has some disadvantages and so on. And in this environment, one way is to find out what is good code or bad code is something like this. So I guess all of you have already seen this cartoon. It's very popular, and in the social media, every few months you see that again, and yet has a lot of truth in it. So it just says the only valid measurement of code quality is what the fox per minute. And when you look at the door on the right side there, you hear a lot of time, what the fuck, what is shit, and so on. And this code seems to be bad. And on the other side, you see the door there, you hear from time to time, what the fuck. And this code seems to be good. So, and what I really like at this picture is that it also shows that the good code has some things others do not like. So that's my point of view, reality. But it's funny, this picture, but it contains a lot of truth, but it does not really help me to, when I write code, how do I avoid what the fox from my review? How can I achieve that? What are the steps that I write better code? And one way is to just listen to experts in these fields, and one expert in PL SQL area is for sure Stephen Feuerstein. And here I showed this screenshot out of this video here. You get the slides on the DOAG conference. I've uploaded them, and the link there too. On my blog post blog, you find the slides there too. And I recommend to watch this video. It's just eight minutes. However, what Stephen just says here, he points out what Tom Kite said: use SQL instead of PL SQL, and it's possible to do that in SQL. A single point of definition, for example, use constants. Write your code in a way that you add logging into your code, so you are enabled to debug it from the outside, set the logging level from the outside, and watch where the code is running through and how much time is spent there. And of course, if you get an error, you should log that too. So this kind of tips Stephen gives there. And you see, and some of these tips you very much agree, and others you don't like. And for a project, in the end, you have to decide what you want. And what happens is that earlier or later, you define some kind of coding guidelines. And when I started at Trivadis, at that time, the guy who wrote the coding guidelines was Roger Troller. And in 2009, he released these guidelines, these Trivadis guidelines, the first time, also on the DOAG conference. And Roger said something very interesting things in the introduction chapter. He said that code is more often read than written. And this is really true. When you write your code yourself, you read it again and add something and read it again. And after some time, when you do bug fixes, you read it again. And maybe also others read that code. So it's very, very important that the code is readable and understandable. And another aspect in this area is that fact that when you write less code, it's easier to read, it's easier to grasp, to load it into your brain. And as a consequence, it's also easier to maintain. So what do we cover typically in such guidelines? One chapter typically covers something boring like the naming conventions. It's really a boring topic, but just let me explain why it is necessary. For example, when we have a PL SQL package, in the PL SQL package, we're accessing the database via a select statement. In this select statement, we reduce the result set by passing in some parameters. And the parameter name may be something like addressing a column name. And of course, we have also the column name in the view behind the select statement, or the table behind the select statement. And the view and the column name and the parameter name must not be named the same way. Of course, you could use the fully qualified parameter name like package name dot procedure function name dot and then the parameter name, but this is really cumbersome. So you end up adding some suffix or adding some prefix to the parameter to distinguish it from the columns. And it's similar with local variables and so on. So you end up with some convention how you deal with that stuff. And in regard of readability, it's easier to read code when this does not change from procedure to procedure or even within the procedure. It's just distracting when you use different naming conventions. So it's boring, but I think it's also necessary, and you can go for sure with a simpler theme than we are here recommending. And another topic is a code style. I showed here an extreme version of code, and this is a typical what the fuck moment. You look at it and say, no, that's bad, that I cannot read it, I cannot maintain it, and even the syntax highlighting does not help at all. So the only thing that really helps is to format the code. And it really doesn't matter if I use an intention of 2 characters, 3 characters, or 4 characters, if I have trailing commas or leading commas, if I write the line, the keywords, if I write them upper or lower, it doesn't matter. Whatever you choose here, it's much better as the other thing here. So you should agree to some kind of code styles. Then, of course, the hard rules where you identify a piece of code where, like in this example, where you say use COALESCE instead NVL. I will show that in the demo a bit later. And of course, also the metrics, the topic I covered in another talk in detail, where you can calculate what is complex code based on metrics like cyclomatic complexity from McCabe. But when you end up in calculating cyclomatic complexity, and especially when nowadays where we do a lot of releases based on 2 week sprints, we need to automate that. And when we want to automate stuff, we need tools for that. And DB Star CODECOP is a tool suite which helps you to check your code. And it's a commercial tool, and yes, it costs something, and yes, it's not really cheap, but it's worth every penny. But whatever, I'm not going here to sell you something. This tool suite has a component, and this component is the SQL Developer extension. And the SQL Developer extension is available for free. So you can check your editor content. It has no size limitation, no limitation at all. Whatever you put there in the editor, you can check it. It doesn't matter if it comes from a file or from the database. So it's very valuable to look at it. It's free. It's not open source, but it's free. So let's go into the demo. I prepared my my favorite guidelines here, and most of these guidelines, when you have a violation of these guidelines, it just shows you a bug. You cannot discuss that this is good. It's one of the what the fuck moments. But I start with some simpler ones, some disputable rules, just to show you how this tool works. So let's switch to SQL Developer. I have here my code, and I can run this code. I said this code is executable, so I show that. And you see, really, this works. No, I don't want to install that right now. So I can, at this moment, also check this code. So we have context menu or shortcut. And then I get here the result, what it doesn't like, the list of issues. I go into that a bit later. What I want to show you here is this report tab. I may enlarge that, and you get a nice little report in HTML. So nice, it's not really nice in Swing, so I open that up in my favorite HTML web browser, and there I have more features, like I can make it larger and smaller and so on. So it's easier to read there. And there you get this information of this editor I've opened here. Some metrics also per unit. and you get also this information about the issues, something like that. What's also interesting here, you have a link to the guidelines, so I can click on this link. I open it up here in a separate tab. And these guidelines we provide here are versions, so this is the current version, and I can also switch to the development version where we already have updated the logo there. And I can browse, for example, look at the coding style section here and look at it online. So, and I have also a link to the GitHub repo where everything is available there for you as well. So you may clone that repository, amend the stuff you don't like, and then generate your own static HTML site with your guidelines. So that's what I wanted to show here. So let's go back to SQL Developer and go back to this issue tab here, where I can click here on these issues, but it's not very convenient. It's really time to format the code. Control F7 and the code is formatted. So let's check the code again. And then I have here, for example, some disputable guideline violations. This G1050 says I shouldn't use literals in my code. I should use constants and so on. And this is, of course, I should consider that, but it gives me a lot of false positives. So this is one of the guidelines I typically going to disable that guideline, and I can do that in the preferences, and I add here just the 1050. I don't like this guideline. I don't want to see ever these guideline violations again. And when I do the check again, I get another violation. The other violation is also disputable, but I'm going to explain you some pros and cons. It says I should label my for loop. And labeling something is just another way of a special type of comment. And this block, when you read it, then you find out that it is printing amount sold of hardware in Asia. So I may put that print, so I immediately see that's what the code is doing here, and I add also the label here at the end. And what I show you here also, it's a kind of bad formatting style. I put that label after the end loop, and it looks like calling a procedure, which is named that way. So formatting will fix that for me, and it's clearer that it's really a label. So when I do a check here, then everything looks good. So this is this disputable rule, and you may ignore it as I've shown you before. But what you can do here in a lot of IDEs, you can fold your code. And when you fold your code, this label stays here visible. And the advantage is that you see, this for loop is doing that stuff. So maybe it has some advantages for you. And this is the last rule I show you, which is disputable. So let's go to the undisputable rules. So in this case, what's the problem? So let's ask DB* CODECOP and see what he's claiming. And it says here regarding, let's make this a bit bigger that I can read it. I should avoid expressions that are equal on both sides. And both sides here mean both sides of this OR. And when I look at this code, it's again one of these what the fuck moments. What the fuck have I thought when I wrote this? Did I have just copied it unnecessarily, or is here missing condition? It is for sure wrong. Nobody can claim and say, hey, that's good code. This is too much. This has to be removed. So I remove that, and let's do a check again. And then again, here I have, here claims this variable is not used, but it's basically in relation of the next violation, where I have here the if, where I see both sides of the equal sign, I have the same condition. And this condition is var1 equals var1. It does not make sense, such a code. It's some kind of commenting in code. I don't like it. We have to change that. It's really bad. So when I do the check here, it's gone, it's good. So this is this kind of rule. And like every rule, you can disable it. But from my point of view, it really makes a lot of sense. The next one is a nice one. I like that because for every customer I run, I found at least one line where something like this exists. A column name equals null. This is always false and is for sure wrong. It should be named is. Of course, it happens, and since this does not throw an error, which it should from my point of view in such a content, it's important to find that out. But I show you also the limitation of these rules. So when I do the check here again, I won't identify an error in this case. But in this case, the code is also wrong. It's a variable here defined, never assigned a value to, and it is also null. So some rules are not 100% automatically checkable. So you have just the rules say, hey, consider when you do an equal, is it possible that this might be null? In this case, I should write something like this, or lcom is null to fix the code. So these are limitations, but nonetheless, this error was for sure wrong. So let's go on with the next example. And this is also a nice one. So let's check the code here. And here, the CODECOP says, I should not use the ROWNUM on the same level as the order by. Why? Let's do a query here. And when I do here the query, I see the results. I get 2 rows. It's these are my top ranks, so 1,600 and 800, but the result is wrong because what happens here is I just query 2 rows in the order how it is physically stored and not really physically stored, how the Oracle database decides to access the data based on index and so on. It can be different. And then I get just 2 rows. And these 2 rows then afterwards are sorted. So the result is wrong. What I should do is typically what I did in 11G, we just executed in a subquery this query, ordered it descending, and then we had an outer query where we reduced the result to the number of rows. The top n query written manually. Since 12.2, we have a better approach where we can write that with fetch next 2 rows. And in this example, I used ties, which is also nice to see. There are 2 with 3,000 salary. I can also say I want only 2, really only 2, and I get the same result as before. But for sure, the error which is reported here is right. This is wrong code, undisputable. Go to the next example, and when I would be in a physical room, I would ask you, and who is really interested in performance? And some of you would say, yes, I like when my code runs fast. And this is something in this area. This rule identifies code which could run faster. And what does it says here? It says, oh, I have used the NVL, and the second parameter is a function. And when this function is slow, I should use COALESCE instead. And why? I show you that by executing this statement. And you see, let's make that a bit smaller. So let me see the whole result. I get 14 rows. So slow function is called 14 times. And 14 times this slow function is defined here in the with clause. And as a first step, it just sleeps 200 milliseconds. So I spend at least 2.8 seconds in this slow function because that's the total time spent here. And then I have a bit of overhead for the resulting for the rest of the query. So that's the reason. When I write here COALESCE as suggested, then it is much faster because COALESCE works differently. It just stops evaluating after the first not null value. And there's just one entry here where the value is null. So it's just called once. So that's the 0.2 seconds spent there. And this query is much faster. This is for sure an improvement. Of course, there are some special cases where NVL is better, but not in this case. So what have we else here? We have got another violation. So what's the problem here? And this is also a bit of a disputable rule. Not really disputable, but I explain it. So you should always, when you write a function, you should think about, is this function really deterministic? And if it is, you should declare it deterministic. Deterministic, difficult word, yes. So, and when I write it this way and do the check, it's gone. But is it really correct? I get the correct result. Is it really good? Is it really deterministic? I can go back to my previous version with NVL and run the code again. And you see, it's deterministic. It's in fact called 14 times, but it's cached behind the scene. So this piece of code is not executed, and this is also not. It just remembers based on the parameter list, which is null here, what are the results. So it's a good thing performance-wise to declare it deterministic. But when it is not deterministic, there's unfortunately not a non-deterministic keyword. It's not possible to define that, and that's sad. I can define it deterministic or nothing. So I would like to have here an additional clause. So what I can do here is to say, yes, I like to have, I know I checked it, it's really not deterministic, and I do add a notes on R, comment it, and say it's not deterministic. And I know I want to ignore that check here. And then again, he says, you should use here COALESCE. Okay, I agree, COALESCE. So, and now when I run the check, everything should be good and the function is fast. So let's go over to the next example. In this example, I have let's do a check first. And here the CODECOP says, this looks a bit fishy. I have a manager here, when manager, and above I have already here got manager. It doesn't matter, could be here, the position doesn't matter. It identifies there a duplication. So this cannot be correct. And when I run the query, remove that one, then I see, in fact, there is a job type missing here, the president. So what I probably meant here and did wrong in my copy and paste job here, I meant president. And when I do the query, run the query again, then it looks good. And when I run the check, I should not see a violation anymore. So again, this really identifies a bug. This cannot be correct to have several when conditions which looks exactly the same. This is for sure wrong code and undisputable that this checks identifies a bug. Good. The next thing is a piece of code. Let's run the check again and explain it based on that. We have here an exception block, and in this exception block, I just print out SQL ROWNUM. Of course, in a production environment, you would log it with a logger utility or Apex debug or whatever, somewhere where you can read it afterwards. But when you just log the error message, you don't get the full information you need. So just to show you that, I run that code here, a script. Small screen, and when I get the result back, I see I get an Aura 1438, which claims that somewhere I used a larger value than allowed, but this code could contain hundreds of lines of code and I have no idea where. So what we did in the past, when it was in the package, we just disabled this code. Old PLC programmer probably remember, and then we just rerun the code. And then I get the information, very detailed, this is really the line and the column where the error occurs. And in fact, SQL Developer starts evaluating here on the declare. So it's this line here on this, in this statement. And then it's much clearer that this expression is causing the trouble. So instead of changing the code, rerunning it, I should, when I start logging stuff like that, I should also include the information of the format error backtrace, because when I run this, I get everything I need. I get the information that I get this original one, and I get also this information at which line this error happened. And this really helps when you debug. So when you take your time and write code to say I got this error, you should also take the time and say where this error happened. So from my point of view, it's also clearly a bug. And it doesn't matter if you do here 2 calls or just put this trace information in the same call. It just looks for, is this call here used? Okay, so let's go further and let's look at this example. Okay, that's a nice one, because old programmers like me, this was the only way we could use in Oracle 8 to get a sequence number into PL SQL. We had to access the dual table. But nowadays, I hope you all are using version 9 and higher. It's not really necessary anymore. So you can nowadays just write this differently, and instead of accessing, doing a context switch and executing a SQL statement, you can do something like this. What am I doing here? Talking and typing is not my best thing here. Okay, so I just rewrite it this way, a simple assignment, and I can remove these 3 lines of code. And remember, shorter code improves readability, and it's also a bit faster. In this case, it doesn't really matter, I think. But in the end, if you do something within a loop, it will sum up. So when I do the check here again, then everything looks good. So security, the next, no, not security. That's not this one. This is a nice one. Let's do just the check. And here it says that these 2 expressions here miss the format clause of this date. So what happens behind the scene? Just the default is used. And what is the default? That's what I've configured here in SQL Developer environment, not in the database in this case. And my default NLS date looks like this. So therefore, this query gives me a result which looks good. But what happens if I change it to the US style of the format, where I say month, day, year? Will this work? Will this query still work? And usually I would ask the audience, and some will say, yeah, it works. No, it will not work. So let's try it out. It works. Based on data, I do not get some high value. So it's interesting. It's working, but I get a different result. So let's try something more extreme. Let's change the current NLS date to ISO format. And let's try to run it again. Again, is it working? Is it not working? In this case, it is not working. I really get a wrong result. So you see, based on my NLS settings, my code is working, is producing a wrong result, or is failing. So nobody is claiming that this is good code. This is a bug. It has to be fixed. So what can I do here? Fix that code. It's quite clear. You can add here a format mask, and then it's defined how it should work. Of course, it's a bit more code to type. And if you're one of them who don't like to add additional code when it's not necessary. You can use also the date literal. The date literal is a bit shorter. It's just defined that you have to type it in ISO format. And from a performance point of view, there's no pros or cons between these two types. Both are good. So yes, I already mentioned that. The next one is about security. About SQL injection and security. When I started programming, security wasn't really a hot topic. That really changed, and SQL injection is still a thing. So when we write in code, we have to check our code. Where do we have code which is vulnerable to SQL injection? And there is a rule to do that. So I can do check here. And it just says, hey, this parameter is not checked, so it's vulnerable to SQL injection, but that's just an assignment here to a local variable. Yeah, okay, but this local variable is used. Come on, what's about code highlighting? Okay, this local variable is used here in this assignment of this next local variable, which contains a SQL statement, and there we have the execute immediate, which executes that. And here we have a vulnerability, and also SQL Developer detects that. Here at the point of the execute immediate, the detection of the code copies here where we didn't do the assert. So in this to avoid that, I can do a dbms assert. I just hope to get working on. SQL name, qualified SQL name. Reality is that this does not work always. So when I do that way and do the check again, and everything is okay. So let's check that also with my code. When I run here dept, then I get this information that I cannot drop it because there is a constraint which is violated. When I say let's try with dept2, then I see this code is added here, but it does not work because dept2 does not exist. But what's with something which is not expected, then I get an information that the DBMS assert has found out that it doesn't look like a qualified name. So that's effective way to identify vulnerabilities, SQL injection vulnerabilities, and get rid of them. Okay, so I come to my last demo, and this last demo is hints. And again, I would ask the audience who is using hints, and of course, everybody's using hints. Sometimes with a bad conscience, but sometimes really necessary. Even in the cloud-based environments, they are still allowed. For certain types of hints are still allowed. So let's look at this example and let's do a check what I get here. And the check says this fast hint might be nice, but it does not really exist. It's a wrong one. And the other thing I see here is I've defined two comments which look like hints, but in fact, based on the definition, just the first one is assumed to be a hint. So I have to change that. So when I change that here, this one gets highlighted. I can run my check again and then get other issues. I see here the information. This emp here is a wrong reference. I have here a table called emp, but I must use here now the alias name. And the dept does not even exist, neither here nor here. So it's really, really wrong. These are these two things which are identified here by the check. So when I run this one, and if you have a newer database, 18, I think it was introduced, that it's possible to see are there unused hints, then I find this one. also. But I have to run the query, I have to analyze it to get this information. This is based on static code analysis, and I get much more detailed information. Why does this hint not work? So I can change it to E and D, do the check again, should be good. And when I run here the query and look at the plan, try it again, look at the plan, and I see that in fact a different plan is used, and I got also the information that now this hint was applied. So I hope you got an impression that there are really some checks which identifies bad code which are bugs and which you should fix, and you see the value of static code analysis. So to sum up the things, or to just get a different perspective, I asked at the beginning, where is my code? And I asked it again, and previously I said, of course, in the version control system, and I hope the answer is now, I hope it is in the database, because when you put the code into the database, there are some advantages, and it's from my point of view, it's quite similar to code, and because data is much more often read than written, and because of that, when I write an application which stores data, I should think at the consumers, and it simplifies the work for the consumers when they just can access the data without doing cleaning ups, using just in case left or full outer joins to do data cleansing. It's just the better way to work. So from my point of view, don't consider only code and fix code, look at your architecture and think about data consistency as well. And with that, I'm 2 minutes over my time, but still some minutes left to answer questions right now. Thank you very much.